Welcome to Sage Audio. Today we're doing a saturation masterclass. But first, if you have a mix that you need mastered, send it to us to receive a free mastered sample of it with the link in the description. Fundamentals of saturation. This is a topic I'm really excited about, so I'm going to go pretty in depth about it. The info from each chapter will build on info from previous ones, so it's best to watch this one in order. Saturation occurs when an electrical component, be it a tube, transformer, or magnetic tape, can no longer handle the amount of electricity being fed into it. For example, with tape saturation, the magnetic particles in the tape have all been reoriented, but there's still more signal being input. This results in both harmonic distortion and compression, which we'll cover in more detail in subsequent chapters. Let's take a quick listen to some saturation so that we're familiar with the effect.
Take everything you find. We stay here until tomorrow. Can't let them win this time.
Saturation's nonlinear relationships. Saturation causes a nonlinear relationship between the input and output. In other words, the signal will be compressed, usually gradually or with a soft knee. For example, if an electrical component has been saturated, then it's likely that for every 3 dB of additional input, I'll get 1 dB of output. In this instance, the ratio would be 3:1, just like with a typical compressor. With saturation, the greater the input after saturation has begun, the higher this ratio. Let's listen to how this compression becomes more aggressive as we push the input's gain.
Take everything you find. We stay here until tomorrow. Can't let them win this time.
If you're enjoying the video, hit the like button. It helps us bring you more videos. Harmonic formation and electrical components. In addition to compression, saturation results in the signal's distortion, which can be observed as harmonics or generated frequencies related to the fundamental frequency. Each electrical component will create different harmonic formations, with the most common harmonics being a second and third order, like with tube and tape saturation, respectively. Let's take a listen to saturation with a second ordered harmonic, then a third, to see if we notice a difference.
Take everything you find. We stay here until tomorrow. Can't let them win this time.
Do even or odd harmonics sound better? Both even and odd harmonics can improve the sound of your signal. However, even ordered harmonics have the unique quality of always being in key with the signal. Since a second order is an exact octave and higher even ordered harmonics are higher octaves, the sound is going to be harmonious with the fundamental. With odd ordered harmonics, they may be in key, but they may also be a note that doesn't coincide with the notes being played in the song. This isn't to say that they sound bad though, as odd ordered harmonics can add desirable complexity to a signal. Let's again take a listen to even and odd harmonics with this information in mind.
Take everything you find. We stay here until tomorrow. Can't let them win this time.
Only a small percentage of people that watch our videos are subscribed, so if you're enjoying the video, consider subscribing. It's free and you can always change your mind. Saturation as upward and downward compression. We talked earlier about how saturation causes downward compression due to the nonlinear input to output ratio that they create, but they also cause upward compression. The harmonics generated both increase low-level detail and cause a psychoacoustic effect that make masked signals easier to perceive. As a result, harmonics lessen the dynamic range, but from the noise floor up. Let's listen to saturation with both downward and upward compression.
Take everything you find. We stay here until tomorrow. Can't let them win
The frequency response of saturation. Just like how various electrical components cause different harmonics and different compression ratios, they impart unique changes to the frequency response. This is in part due to the harmonics, since these add signal to various aspects of the frequency range, but it's also due to the properties of the component. For example, slower tape will attenuate high frequencies while amplifying lows. Although this aspect isn't directly caused by saturation, it'll often be directly tied in with saturation since we're using these components or emulations of them to saturate the signal. Let's take a listen to tape saturation with a slower speed and notice the truncated top end and accented lows.
Take everything you find. We stay here until tomorrow. Can't let them win this time.
What makes a good analog emulation? While we're on the topic of analog emulation, it might help to know what differentiates a good analog emulated saturator from a not so good one. In short, it comes down to how many nuances of the original hardware have been accounted for and how accurate it's been emulated. So, a good saturator will account for the nonlinear relationship as it relates to the incoming frequency and that frequency's amplitude. It may also account for mild stereo expansion from crosstalk between an incoming stereo signal. And as we covered, it should account for the unique harmonic formations that occur as they relate to the component, the incoming frequency and amplitude, as well as a lot of other factors. Let's take a listen to Satin by Yuhi, a tape emulation that I think accounts for a lot of the nuances that we discussed here.
Take everything you find. We stay here until tomorrow. Can't let them win this time.
If you're enjoying the channel, support us by joining with the link in the description. Saturating with a regular compressor. If you have an analog emulated compressor that you like, you can use it for saturation by driving the input while reducing the output. Additionally, you can introduce your compression as you normally would, but set the quickest attack and release times possible to add additional harmonic distortion. If we think of saturation as a combination of compression and harmonic distortion, then we can use a lot of different plugins to cause saturation. Let's take a listen to compression being used as a saturation plugin.
Take everything you find. We stay here until tomorrow. Can't let them win this time.
Frequency-specific saturation. Frequency-specific saturation has been around since the 1970s when the first exciters added harmonics to the high frequency range of a signal. Today, we can use a multiband saturator to affect different ranges. For example, I could add tube distortion to my lows and tape to the highs. The tube distortion will cause some lower ordered harmonics, while tape will cause a smooth sound and a third ordered harmonic. Let's take a listen to these settings.
Take everything you find. We stay here until tomorrow. Can't let them win this time.
Modulated saturation. Recently, modulated saturation has become an option in which you can add multiple envelopes and oscillators to affect how the distortion and compression occurs. For example, I can create an ADSR filter and attach it to my drive dial to cause saturation to varying degrees, depending on the incoming signal. Let's take a listen to modulated saturation and notice how it can be used to create unique saturation that isn't possible with typical saturators.
Take everything you find. We stay here until tomorrow. Can't let them win this time.
If you have a mix that you need mastered, send it to us to receive a free mastered sample of it with the link in the description. Thank you so much for watching.